guys, welcome back to Pandas part 7. So in this part, we are not just learning new syntax, just to memorize it. We are learning how analysts think, then they look data, all that. We will go step by step and I will explain why before how. Okay, so let's start. First of all, we need to load the dataset. Here, I already uploaded the dataset as we already do this several times. So from here, you can take uploads and upload it from here. You can upload the HR employee attrition. I changed the name. So everything was already discussed in previous classes. And also I provided the link above to show where the dataset lies in Kaggle. And to know how to download a dataset from Kaggle, you can go through my shorts. I will tag it in this video. Okay. So let's start. First of all, I need to import pandas as PD. So we can work with pandas, we can use just PD. And afterwards, we need to read the CSV file. For that, we are also placing the CSV file in df, and df equal PD dot read CSV. And we are placing the name HR employee. Attrition.csv, and afterwards let's run with df.head. So we can understand the first 5 rows. Okay, so here we get the outlook of our HR employee attrition dataset. Now we have 5 rows and 35 columns. So we started by loading the dataset, and then we got the output that HR dataset we imported from Kaggle. So this is how real analytics projects work. This is our first step. As we always do, we can just go through df.info to know what's happening and all. So here we find 35 columns, and we get the memory usage as 402 KB. We can also understand the data types, which is int, object, all that. So every information is already placed above, that is 1470 entries, and which is 0 to 1469 rest columns. The column name is avoided. So that's how it works. Okay. Now our main case, that's we are going to select only the useful columns. That's our important habit an analyst should have. So for that, I'm using calls equals. We can add the employee number from here. You can just take it from here. So add the employee number and then the department. Also, we can add the job role. You can also just take it from above. Okay, here you can see all the column names. And we need some more, that's monthly income. And year at company. Also the job satisfaction. And at last, we can add the performance rating. So we add our this much things and about 7 of them. Now we will give df equals. We are placing df as df dot calls. So now df is only considering these columns, not other of that. Okay, so and we are also giving df dot head. Okay. Now we got an error here. We found some error that's not in the index. For that, we can go through this and understand where we find the error. So while we go through this code, we can understand that here the we gave year at company, which is not in the index. So we need to find what it is written here in the real CSV file, that's years at the company. So we need to remove year to years. Also here it's provided not only years at company but also employee number. So here we are giving an extra space in pandas, it counts. So we need to erase that too. So we are removing that space. Now let's run. So that was our problems why we are doing index. And then we can also see that it is mentioned as key error while the index is not matching. Okay, we remove this and run. We will get the output. In real projects, we don't use every columns as we do here. We only keep columns that help us to answer the questions, which make analysis clearer and less confusing. Okay, now we need to sort the data. For that, I'm using sort values. We use sort values several times, so we know how to sort data. Okay, df, and which is equals to df dot sort values, and we are placing the employee number here, and then we need to add years of the company. Okay, so here we gave two of the column names. Run this, and Windows function depends on order. If the data is not sorted, the result can be misleading. Because of that, we sort the value before doing the next process. Here, we take years of the company, which act like time. And we are telling Pandas to look at each employee's journey in the correct order. So, while we go through the employee number and the years of the company, we can understand the time period. And from that, we can get the employee's journey. Okay, we can sort the order of it. That's how we use sort values here. So, before writing Windows function code, let's understand the idea. Okay, group by gives us summaries, and Windows function let us compare each rows and the rows with group without losing any rows. Okay, so we yesterday we learned about group by. What it shows the average sum, and it do arithmetics operations, all that. It also give transform, and we use apply, transform, aggregation, all this in group by. That's almost the summary of our csv file. But while we come to windows functions or window function, here we compare each rows with its group without losing any rows. Okay, now we are really comparing the rows as we do yesterday. We compare rows using transform, and now here also we are doing that. Now we need to compare the salary with department average. For that, I'm using DF. We are making debt average salary, average income. Here we are using DF dot group by, and we need department with the monthly income. Okay, then we are using dot transform with mean. Okay, we may get the error because we need everything in a single bracket. Okay, so we need to provide everything in another bracket. Let's run. Now, what we really do here, something important, that we are using transform, not AGG. Why? Because we want the department average on every row, not only one value per department. In AGG, we are not getting the values in every row, so we are taking transform, which help us to get the average of every row. And we need to compare the employee salary vs department. Before that, I need to generate df. Now the df is actually changed. We get the company's department, year, job satisfaction, all that. You can also see df department dot average income, and it is also present here. We get each row has its own average income because we use transform instead of AGG. Okay. Now, what we are going to do? We are going to compare the employee salary with department average. For that, here you can, if we change this here, it will change the whole code. So before that, we need to drop it and do everything. It will definitely gonna create another one. So here we get department average income and two department average income. So we need to drop one of it. So the problem will be solved here. So to drop this, we can go through df.drop. Okay. Now when we run this, we can get another snippet. We can just stop df.drop. We are placing the department dot average income. Not this actually, the other one. Okay, let's use this. Change the hyphen. And what if we run this? It will give a error because it shows it is not found in axis. So if we get such errors, we can just give the axis as it's in a column. We can provide the axis as 1. Let's run again. Now we get the output. We can go through this, and the department average with hyphen is now deleted or removed. Okay, we can also use df dot drop with column equals department dot average. I mean this one. So it can also work. And if you have any confusion with this kind of code, you can also, I am having a confusion. So I'm checking it in using Gemini. Okay, let's run and ask, can you correct this code? So now it will give the correct code. If we are confused with any of our code, we can just use this because that's a good idea. And we don't want to get so messed up here. Now it provided the correct code. Okay. So we can accept it. So it will be definitely print in our snippet, or we can just accept and run or just cancel. Okay, that's fine. So that's how this part work. I just give you just for your knowledge. Okay. And with control plus Z, we can undo the operation. Okay. So here there are many other ways to do this, but some of the ways are using axis or just placing the word column. Both are actually right. Okay. So from the below, we understand that we don't need this bracket, and we need to give this as columns. Okay. So this could also work here, and we can also give just axis 1, which is also possible. Okay. Moving on. Now we need to compare both employee salary and department average. So for that, we are taking df above depth average equals, we can add monthly income, and which is greater than the df of depth average income, and we can also give df dot head. Now we get hit. Also it provide the monthly income which is greater than depth dot average. Okay, so now we can see whether each employee earns more or less than their department average. As we done in last class, we compared the rows itself, and we get here we get everything as false. As we know, the department average is greater, and we get the monthly income comparison with department average, also the above department average. So it shows false. That means all these are under the average salary of department, and this is how real analysts think. We can also see that what we had removed is also here. So why it happened means we just give df dot drop, and we didn't mention that where it is placed. Like if I have mentioned, we can cut it. So we can copy this and let's paste it here. Add the columns. Also provide as df equals. Okay. And run this again. You will find the difference. Now, the df has no department average with hyphen. It is removed. Last time we just done as general and we didn't place that to df. Now we placed that operation inside df. Okay. So now we need to do ranking inside employees. For that, we are using df depart. I'm sorry. We need department rank. And we need to add df dot group by. Also, we can add all this. We can just accept that head as we do every time. So here, we give a department with depth rank. Okay, so it will be placed in our main data frame, and we proceed it with department and monthly income. Okay. Also, we place the ascending as false, so it should be given in descending. So as we look here, we can see the depth average rank or the department rank, and now worth which has the highest rank, which has the lowest. All this can be noticed from this. Ranking really help us to answer questions like who are the top earners in each department, and this is how extremely common in HR and finance analysis works. Okay, so here we can also find that laboratory technician has the rank of 910 and sales has the rank 215. So the rank is 215 is highest here. Okay, now we need to do cumulative income over time. For that, I'm using cumulative income. That's we are placing the name as df with cumulative income, and also we are providing that with our group by itself, df dot group by, and we need employee number here with monthly income. Also, at last we are giving Kim sum. Okay, sometimes I get just bit confused with the spelling cumulative. Did you guys got the spelling? Okay. So cumulative sum shows the growth over time. Okay. We can also call the df. So it's already provide all this, all the columns. And if we just give the head, we only get the head. Okay. So here you can see another column that is cumulative income. And that's how that's what shows the growth over time. Now we are no longer looking at one salary, we are looking at the employee's journey, the average income, the rank, the cumulative income, all this together. Now we need to add the change over time, actually the difference. For that, we need to make another column name which is income change, and for that we need df dot group by with employee number and monthly income itself. And afterwards we are adding the diff dot diff. Okay, run this. We need the df dot head also. So Okay, so column not found monthly, we didn't add the income. So here the diff compares the current rows with the previous row. Okay, that shows the real difference. And after it run, we will get rises, drop, stagnation, all this. Okay, so this is how we get our difference, and it will really help us to see the races if there are any drop or stagnation, all this. Okay, so it may take a bit time. Okay, so if this happens to you too, you can just cut it, paste it in another cell. Okay, we get it. Okay, while we have such lagging time, we can just go through deleting that cell and placing it in another cell. Maybe that's because of some glitch. Okay, so what all we get? We get income change, we get department average, above department average, debt, cumulative income. All these were done by us. All this shows how it really works. Okay, so I hope there is some error might happen in between. Okay, let's find it where. So while I go to the code, I couldn't find any error. So this is how it might look like. Okay, and yes, now the key takeaways. Group by summarize, as we said above, group by summarize what happens here, and then window function explains the movement. Okay, so now everything is changed. We had a little error while running that have a saving issue. Now we got the income change, and 1, 2, 3, 4. All this is placed here, and that's how the difference help us to know about raise or drop or stagnation, all this. Here we found it, and we can understand how to find the income range and all. Okay, this is how analysts think, not how they code. They first think about what they are doing, what they are performing, all this before beginning their code. If this felt slow, that's good. Understanding is more important than speed. In the next part, we will go even deeper and apply the thinking to real business questions. So I'll find you in the next part. See you guys.